Okay, so this is the last section in the unit. This is 5.7, interpreting graphs of linear functions. So each graph below shows the temperature capital T degrees Celsius as a function time T hours for two locations. Location in temperature temperature in location A has a slight increase. We can see that if we look at this, the point where the graph intersects the horizontal axes is 4, 0. The horizontal intercept is 4. This is also known as the x-intercept. The point of intersection represents the time after 4 hours where the temperature is 0 degrees. The point where the graph intersects the vertical axis has coordinates 0, -5 because x equals 0. The vertical intercept is -5. This point of intersections represents the initial temperature. Our domain is 0 less than or equal to t less than or equal to 12, and we can see that because it has stop points. We need to stop. The range, same thing. Initial is -5, up, all the way to 10. Our rate of change is the change in the dependent over the change in the independent. So 5 degrees Celsius total, so 10 minus, and then, the change. So it goes a change of 5 degrees, and change of T is 4 hours, and we simplify that to 1.25 degrees Celsius per hour. In location B, we can see that this is decreasing, so that'll change something for sure. This talks about our horizontal axis point and our vertical axis point, our domain, our range, and the big thing that we can see here is that our rate of change is negative. So if our rate of change is negative, we should expect that our linear function should be decreasing, going downwards. Now, if I am determining intercepts, domain and range of a graph, this graph shows the fuel consumption of a scooter with a full tank of gas at the beginning of its journey. So my vertical is here. So my vertical point is 0, 8. This is also the y-intercept. If I'm looking for my horizontal one, it's here. So h such that 200, 0. This is also the x-intercept. The domain is 0 less than or equal to little d less than or equal to 200. And my range is 0 less than or equal to v less than or equal to 8. Sketch a graph of the linear function using intercepts. So to find the x-intercept, y must equal 0, or f of x equals 0. It's the same thing, just two different ways of writing it. I just want you to be aware. So this would be 0 is equal to -2x plus 7. Subtract 7 over. Divide by -2. And we get 3.5 is equal to x. So that means we have a coordinate point at 3.5, 0. So we plot that. 1, 2, 3.5. When we find the y-intercept, x equals 0. So then we plug that in. That is f at 0 is equal to -2, 0 plus 7, 7. So we have a point at 0, 7. So that should be all the way up here. And then we get a little line out. For you, your ruler, to draw a straight line, please. And then you just connect your dots as best you can. Kind of neat, kind of like they look like they're crossing. And it should extend all the way to the end, or make sure that you have your little arrows on it like I do, because that signifies that it goes on and on forever. Matching a graph to a given rate of change in vertical intercept. So which graph has a rate of change of 1/2 and a vertical intercept of 6? Justify the answer. Well, if I'm looking solely at this, I see that my graph should be increasing. This is the only one that is increasing. They both have the same vertical intercept, but this one is increasing, and my rate of change is increasing. We kind of briefly talked about that in the last one, so that is kind of the key giveaway for that. Solving a problem involving a linear function. This graph shows the cost of publishing a school yearbook. The budget for publishing costs is $4,200. What is the maximum number of books that can be printed? So if I find the rate of change for this, and it's 1,000 because it goes up by 1,000 over 50, we get that we can have $20 per book. So that is my rate of change. I can plug that into a formula now. I can say cost is equal to my rate of change times the number of books I want plus my initial. Now that goes way back to one of the earlier sections when I showed you all the different ways to identify a linear relation and had the little bit of the function. So this is the independent. No, this is the dependent, sorry. Dependent. This is the independent. This is the rate of change. And this is the start value, I think it was called. It might have been called something different. We'll call it something different as we go along here. So then if I want to know how many books I can be printing, and I know that I have a budget of $4,200, that is my cost. First thing I have to do is I have to subtract 500 over. So that leaves me with 3,700 is equal to 20n divided by 20. And we get 185 is equal to n. So we can only print 185 yearbooks if that is our budget. That's it. That's all. Go on to the review. Go on to the practice test. Let me know if you have any questions.